multiply 1/2 times -4. -2. So cosecant equals -2. Okay, and then how do we get the theta alone? Inverse, cosecant inverse, cosecant inverse. Okay, so theta is cosecant inverse of -2. Okay, and then cosecant corresponds to what? Sine. So when we look at the unit circle, we're going to be looking at a y-coordinate, and -2 is the flipped version of what fraction? 1/2, -1/2. Okay, so we're looking for a y-coordinate that is the flipped version. Well, it's -1/2 is what we're looking at. So y-coordinate of -1/2 would happen where? 7π6 and 11π6. Okay. All right, what's another one we should look at? 2? Okay, what does number 2 say? Okay. So what do we have to do for this one? What do we have to do here? Divide by 1/3. So we have secant theta is √2/3/1/3. And we know that if you have a fraction divided by a fraction, you should keep it, change it, flip it. So I'm going to say secant theta is keep it, change it to a multiplication problem, flip it. The 3's cancel out, and we get secant theta equals √2 . And then to get the theta alone, we would do the inverse of each side. So theta equals secant inverse of √2. And secant corresponds to which trig function? Cosine. Cosine is which coordinate? The x-coordinate. So we're looking at the x-coordinate, and √2 is the flipped version of what fraction? √2/2. It's the flipped version of √2/2. So we're looking on the unit circle for an x-coordinate of positive √2/2. Pi-4ths and 7 pi-4ths. Okay. All right, what else do we need to do? We good with those two? Yeah? Okay. All right, go ahead and make sure that those assignments are all turned in. You got your name on them. And then for today, we are going to do a little bit of a factoring review just to make sure that factoring is in your brain. That's fun. I mean, it doesn't think you have a gun, it thinks you have metal, and then they just have to make sure.
The crazy thing is, though, I haven't had to take my iPad out or my Bible out, and now they want me to take everything.
Yeah, it might be they made it more sensitive today.
Well,
Yeah. All right. So we're going to take some notes. We're going to do a little bit of a factoring review just to make sure that you guys are cool with factoring. These numbers for the factoring are going to be a little bit bigger than what you're going to have to do today, but today we're going to look at, we're still going to be solving equations, but we're going to be solving equations where with the trig, it's going to require you to factor and then solve a trig equation. So we're going to up the difficulty just a little bit. So I'm just going to make sure that we still remember how to factor things just by practicing some basic factoring with x's first before we get into the factoring with trig. So let's do a couple of these. I pulled these from my Math 3 class, so some of these, the numbers are going to be bigger than what you're going to see today, but we'll practice them anyway. So let's do this one first. X squared minus 5x minus 36. Let's make sure we remember how to factor something like this. So what do we do if we're factoring a problem like this? We make an x. We look for two numbers that multiply to something and two numbers that add to something. Multiply to negative 36 and add to negative 5. So what are two numbers that multiply to negative 36 but add to negative 5? Nine and 4. Would that work? Negative 9 and 4. Negative 9 and 4. Okay. And so then our factors would be x minus 9, x plus 4. Okay, let's factor x squared plus 2x. What type of factoring is this? Greatest common factor, it's GCF. GCF factoring. So when we do GCF factoring, what do? We take out what's in common, which in this case is the x. And then what do? It would be x plus 2, so then we write the leftovers x plus 2. Okay. Okay, here's another GCF problem. So 2 would be part of the GCF because 2 goes into both. And then they still also have an x in common, so we're still going to take the x out. 2x plus 3. Okay. All right, what type of factoring is this? Difference of squares. So everyone see that 9 is a perfect square. What's the square root of 9? 3. So if you guys remember, difference of squares gets two sets of parentheses. One has a plus in the middle, one has a minus in the middle. And then what are the parentheses going to be? X plus 3, x minus 3. Okay. All right, let's do x squared minus 6x plus 5. Okay, so we need to make the x. Okay. Say that again. -1, -5. Okay, so x minus 1, x minus 5. Okay, what if I took this problem right here? I'm going to change it up just a little bit. So that was number 5. Okay, so number 6. I'm going to say, instead of x squared, I'm going to say 2x squared, and then I'm going to say minus 7x plus 5. So I'm changing it just a little bit. How does that change the problem if I make the front a 2x squared? Distribute the 2? What do you mean by distribute the 2? Okay, so what type of problem is this? It's a slide divide problem because there's a 2 in the front. So we're gonna do 2 multiplied by 5 is 10. 2 times 5 is 10, so we're multiplying to 10 and we're adding to -7. So what numbers would multiply to 10 but add to -7? -5, -2, okay. Then what do we do? So we're going to have x minus 5 and x minus 2, but we're not done because the name of this is slide divide. So Carly said divide by 2. Yep, and then if it doesn't divide, you bottoms up. So 5 over 2 doesn't divide, it doesn't reduce, so we bottoms up that one. 2x minus 5. And then what do we do with this one? It divides, so we make it a 1. 2 over 2 is 1. Okay, let's try 2x squared plus 3x plus 1. All right, what do we do here? So we're going to slide the 2 over to the 1. 2 times 1 is 2. We're multiplying to 2 and adding to 3. 2 and 1, okay. So we've got x plus 2 and x plus 1, but we're not done yet. The number that we slid is the number we divide by, so we're going to divide by 2. So this one is x plus 1. 2 over 2 is 1. Two x plus 1. Bottoms up, so 2x plus 1. Okay. How are you guys doing memory-wise? Are we kind of remembering how to do those? Yeah? Okay. The nice thing about the trig problems is that the numbers on these tend to be kind of small when you run into them. So they're not like the most complicated factoring problems you've ever seen. But when you run into them, they are in terms of trig. So that is, not the most fun thing. Okay, so today we're going to be looking at quadratic trig equations. Quadratic. Trig. So it's going to feel similar to yesterday, but with solving some quadratics. Okay, so we're going to solve on the interval from 0 to 2 pi. This is the same interval as yesterday. I just wrote it using the interval notation instead of using the inequality notation that I did yesterday. So it's the same instructions as yesterday, just written slightly differently. So we're still finding the answers on a unit circle. If we have the spot where 0 and 2 pi are, I'm including 0 as an answer, but I'm not including 2 pi as an answer. So same thing as yesterday. Okay, so let's go ahead, and the first few are not really going to be factoring. They're still going to be quadratics, but they're not really going to be factoring. They're going to be problems where you could take a square root to get the answer. And I'll show you guys when we get to the factoring problems what makes these a little bit different. Now, when you see this notation, there's two different ways to write it. So this is the shorthand of the notation. This is how you're always going to see it printed because this is how people just always write it in general. Now, we can leave it as cos squared theta, or if you guys would prefer, we could say that the first step in the problem is to rewrite this as cos theta squared. So are you guys okay with seeing it written like this, or would you guys like to say that our first step is to rewrite it? What do you guys prefer? Would it mess with you to see it written like this? Doesn't mess with you? We understand that this really means this. They're just being lazy and not writing parentheses. We're not going to forget that. This means cos times cos. We're good with that? Say that again? Okay. Okay. All right, so let's go ahead and start working this through. So if I want to isolate the cos, what is the first thing I could move over to the other side? Yeah, I've got a -4 that's just sitting there, and then I have this -4 that's being multiplied. So I can't move this -4, but this -4 I could move. And how do I move it? I add the 4. Okay, so I'm going to say +4, +4. Okay, so now I've got -4 times cos squared equals -1. Okay, and then at this point, if I want to get the cos alone, what should I do with this -4? Divide by -4, divide by -4, okay? So I've got cos squared equals a negative over a negative is positive, so I've got +1/4, okay? Now this is cos, in parentheses, squared, so how do I make it so this is no longer squared? I square root it. And when you square root something, do you have one answer or do you have more than one answer? You have more than one, right? You always have a plus minus in front of a square root. So whenever I take this and I square root something, I'm always going to get a plus minus in front of this. And then over here on the left side, the square root and the squared, those cancel out. So I have cos theta. And then over here, I have to think about what's the square root of the top of the fraction, what's the square root of the bottom of the fraction. So the top of the fraction is just the square root of 1. What's the square root of 1? 1, okay. The bottom of the fraction is the square root of 4. 2, okay. So on the top, I've got plus or minus the square root of 1, which is 1. On the bottom, I've got plus or minus the square root of 4, which is 2. So I've got the positive version, which is 1/2, and I've got the negative version, which is -1/2. And that's because I had plus or minus. Positive 1/2, -1/2. Does that make sense? Okay. And then for each of those, I've got the inverse. So I've got theta equals cos inverse of 1/2. and it equals cos inverse of -1/2. So I've got two options there. So now I'm going to pick up my unit circle and I'm going to say, okay, cos, so I'm looking at the x-coordinate. The x-coordinate for +1/2 would be what? Where is the x-coordinate +1/2? Pi thirds and 5 pi thirds. Okay. And then where is the x-coordinate -1/2? Okay. 2 pi thirds and 4 pi thirds. Okay. So there we go. So if a regular trig equation had two answers, then when we have a quadratic equation, it just doubles that. Now it's got 4 answers instead of 2 answers. So that's kind of what we're going to expect for these problems. Okay. All right, let's try another one. All right, 4 equals 4 cos squared theta plus 1. Okay, so how could I start getting cos alone? Subtract the 1. Okay, so I've got 3 equals 4 cos squared theta. Okay, then what should I do? Divide by 4. So now I've got the fraction 3/4 equals cos squared theta. Okay. And now what should I do? Square root it. And if I square root it, how many answers do I get? 2. I get the plus version. I get the minus version. My square root and my squared cancel out. So I get cos theta. And then I'm going to go ahead and I'm going to square root the top and I'm going to square root the bottom. So on the top, can I square root 3? No, so I'm just going to write the top as the square root of 3. On the bottom, can I square root 4? Yeah, what do I get? 2. So I get square root 3 over 2. I'm going to get the positive version, and then I'm also going to get the negative version. So I get positive root 3 over 2. I get negative root 3 over 2. Make sense? Okay. So now I'm going to go ahead and say I've got my 2 answers here. If I was to do the inverse, I would say theta equals cos inverse of positive root 3 over 2. And theta is cos inverse of negative root 3 over 2. And so because we're dealing with cos, we're looking at the x-coordinate on our unit circle. So I'm going to look at the unit circle, look at my x-coordinates, and see where the x-coordinate is positive root 3 over 2. And what do I get? Pi over 6 and 11 pi over 6. Okay, and then I'm going to look at the unit circle and see where my x-coordinate is negative root 3 over 2. 5 pi over 6 and 7 pi over 6. Okay. How do your brains feel? Pretty good? Okay. All right, let's do tan squared plus 2 equals 5. All right, what should I do here? Okay, I'm going to minus the 2. So tan squared equals 3. And then what do I do? Square root it. And whenever I square root, I get two answers, plus and minus. Okay? My square root cancels with my squared. And I get tan theta equals, I can't square root 3, so I'm just going to leave that underneath the radical. So I get the positive version, positive root 3, and negative root 3. So when I solve for the angle, I get theta is tan inverse of positive root 3 and tan inverse of negative root 3. So that means that my answers are going to be where I look on the unit circle and I can see that the y coordinate divided by the x coordinate simplifies to root 3. So where on the unit circle does the y divided by the x simplify to a positive root 3? Pi thirds and 4 pi thirds, okay? So the positive root 3 is pi thirds and 4 pi thirds, okay? And then where does the y divided by x simplify to a negative root 3? 2 pi thirds, 5 pi thirds. Yep. Okay, so these ones were not problems we had to factor. These were pretty simple. The way that you can recognize if the problem needs to be factored is that in the problem there is only x squared terms. There's only cos squared, sine squared, tan squared. There's only squared terms. That's how you can recognize that you can solve the problem by taking square roots. Okay? Now, if the problem has a cos squared and a cos, or it's got a cos squared and let's say, well, a cos squared and a cos, a sine squared and a sine, a tan squared and a tan, it's going to have to be factored. If it has a tan and a sine, or a cos and a sine, or a tan and a cos, or something like that, then you're going to have to factor, but it's probably going to be a GCF factoring. Okay? So if it's got a mixture of stuff, that's when you're going to have to factor. All right? If it only has something squared, though, taking square roots is going to be your best option. Okay, so now I'm going to draw a little line here. So up from the line, I'm going to say taking square roots. Taking square roots. And then down from the line, these are going to be factoring problems. All right, example 4. All right, let's do cos theta equals negative 2 cos squared theta. So when we solve by factoring, we always want to take the equation and we want the equation to equal 0. And the squared term should have a positive coefficient. We want the number in front of the squared term to be positive. So right now I have things on both sides of the equal sign, and the number that's in front of the squared term is negative. So when I start this problem, I want to take this term right here and I want to add it to the left side. That's going to make the problem easier for me to factor. So I'm going to start by adding 2 cos squared to the left side. So the problem that I'm factoring is 2 cos squared theta plus cos theta equals 0. And anytime you have a hard time figuring out how to factor this, what I like to do is just write it in terms of x off to the side. So this would be like factoring 2x squared plus x equals 0. That's exactly what you're doing. So can you guys tell what the GCF would be for this problem? It would be just cos. So we're going to factor out a GCF of cos. And we're going to write our leftovers. So if we take out a cos, what's going to be left over? 2 cos plus 1. So when we have factored something, once we're done with the factoring process, then we go through and we take each of the factors and we can write down that they equal 0. Or if you're comfortable with the shortcuts, we can do the shortcut. So here we know the factor in the front, x would equal 0. This one, we would have the x equaling a fraction. Do you guys remember how that works? If it just said x plus 1, x would equal -1. But since it says 2x plus 1, then x would equal -1 divided by 2. So it would be x equals -1/2. Now over here, we don't have x, we have cos theta. So instead of saying x equals 0, we're going to say cos theta equals 0. So here, cos theta equals 0. And over here, instead of saying x equals -1/2, we're going to say cos theta equals -1/2. Does that make sense? So for this answer, we're going to say theta is cos inverse of 0. And for this answer, we're going to say theta is cos inverse of -1/2. So if we look at the unit circle, we're looking for where an x coordinate is 0. Where do you see an x coordinate of 0? Okay, so pi halves and 3 pi halves, okay? And then over here, we're looking for an x coordinate of -1/2. 2 pi thirds and 4 pi thirds. Okay, how do your brains feel? Pretty good? Okay, let's try another one. Okay, for this one, we're going to do -4 sine theta minus sine theta tan theta equals -3 sine theta. And I'm still going to write it off to the side using x's, and in this case y's, because it's kind of like we have two variables. So I'm going to say we've got -4x minus xy equals -3x. Do you guys see how these are comparable? -4x minus xy equals negative 3x. That's kind of like what we're working with. So we need to make this problem equal 0. What do you guys want to do to make it equal 0? Add the 3 sign, okay. Okay, so I'm going to add the 3 sign. It's okay if we do that because we can take out the negative. That won't be too bad. So we're going to have negative sign minus sine tan equals 0. So can you guys see what we should take out as a GCF? We should take out a negative sign. Does that make sense? So we've got a negative in each piece, and we've got a sign in each piece. So we're going to take out a negative sign. So for the first piece, if we do negative sign divided by negative sign, we have a 1 left over. And the second piece, if we take out a negative sign, what's left over? A tan. So what should I put in here for the sign? A plus or a minus? Plus. So plus tan. Okay, so if we were factoring over here, what would we say the x in the front equals? 0, right? Does the negative in the front make any difference? No, so we would just say that x equals 0. And then what would we say about the y? Not 0. Is 1 plus y any different than y plus 1? So y would equal negative 1. 1 plus y and y plus 1 in parentheses are the same thing. They're just in backwards order, but they work the same. So this y over here would equal negative 1. Okay, so let's go back over here and let's solve it with trig. So here we have sine theta equals what? 0. And here we have tan theta equals negative 1. Okay, so theta equals sine inverse of 0, and theta equals tan inverse of negative 1. So when we look at the unit circle for sine, we're going to be looking at the unit circle and we're going to find the y coordinate of 0. And then for tan, we're going to look where the y coordinate divided by the x coordinate simplifies to be negative 1. Okay, so y coordinate, where on the unit circle is there a y coordinate of 0? 0 and pi, and we know that 0 is in the same spot as 2 pi, right? 0 and 2 pi are coterminal, but our instructions told us not to use 2 pi as an answer. They said on the interval use 0 as an answer, but don't use 2 pi as an answer. Okay? Where on the unit circle does the y coordinate divided by the x coordinate simplify to become negative 1? 3 pi fourths and 7 pi fourths. Okay. All right, how do we feel? We okay? All right. Let's try one that has factoring in it, like regular factoring. So this one is 3 cos squared theta plus 1 equals 2 cos theta plus 2 cos squared theta. So if we were to write this with x's, this would be 3x squared plus 1 equals 2x plus 2x squared. That's the problem that we're working with. Okay, so if we were to start the problem off by trying to make it equal 0, what would we do first? I probably wouldn't minus the 1, because when we factor, we like for our x squared term to stay positive. So I probably want to get everything over to this side where the 3 is already positive and it's the biggest x squared term. I probably want to move stuff over here. So I want to take this stuff on the right side and I want to move it over to the left side. Does that make sense? Okay. So I'm going to subtract the 2 cos squared. And then subtract the 2 cos. So 3 cos squared minus 2 cos squared gives me just a regular cos squared. And then I've got minus 2 cos. And then I've got a plus 1. So this is what I'm working with. So how do I factor something like this? So I'm looking for something that multiplies to 1 and adds to -2. -1 and -1. So what would go in my parentheses? So cos theta minus 1, cos theta minus 1. So when we solve these by factoring, we're going to get the same answer twice, right? Both of these would be just x equals 1. So over here, when we solve this, we'd get the same answer twice. We're going to get cos theta equals 1. So theta equals cos inverse of 1. So we're looking on the unit circle where the x value is 1. And what do we get? Just 0. Yeah, this is where you get 0 and 2 pi, but we know that 2 pi is not an answer we can write down because it's on the interval, and 0 is the only answer we're supposed to write down. 2 pi is not supposed to be included. Okay, I think that what I'll do is let you guys work on some of these and then maybe have you guys tell me which ones you would maybe like for me to do. So I think for now we're going to maybe just work on the front side of this page so that we don't feel overwhelmed. So I'm going to have you guys start with numbers 1 through 8. So just remember, if the problem only has a tan squared or it only has a cos squared, then you're going to take a square root to solve it. If it has more than that, then you're going to be factoring. Okay, that's the first thing you're going to look at in the problem. So if we look at number 1, I can see a sine squared and a sine. Are we going to take square roots to solve that problem, or are we going to factor? We're going to factor, yeah. So number 1 is a factoring problem. Number 2 has a sine squared and a sine squared. Are we going to take square roots to solve the problem, or are we going to factor? We're going to do square roots to solve the problem because it only has sine squared. Number 3 has a tan and a tan squared. Are we taking square roots, or are we factoring? We're going to factor because it has a tan and a tan squared. It's got both. Okay, we got a cos squared and a cos. Are we taking square roots or factoring? We're factoring because it's got both. It's got a cos squared and a cos. Number 5 has a sine and a sine squared. Taking square roots or factoring? Sine and a sine squared. Factoring. Number 6 only has a sine squared. Square roots. Number 7 has a cos and a cos squared. Factoring. Number 8 has a cos and a sine. Factoring. So if it only has a square, something squared, sine squared, cos squared, tan squared, if it only has a squared, that's when you take a square root. If it's got a combination of anything, that's when you factor. Okay?